Okay, we are going to go over what you need to know for the Chapter 2B test. So, first of all, you're going to have lots of solving quadratic equations. So, solving quadratic equations, all kinds of different types. And what you need to know is you definitely need to set your equation equal to 0, and then after that you want to factor, you could factor it, you could complete the square to solve it, or you could use quadratic formula. And so you're going to see all kinds of types. You definitely want to make sure that you factor out a GCF first. So if there's a common factor, you want to factor that out first. You might see the difference of two squares, right, where it's a squared minus b squared, and that factors as a plus b times a minus b. And you might see factoring by grouping. That's when there's more than 3 terms, right? If there's like 4 terms, you could do factoring by grouping. You might see the sum or difference of 2 cubes. And that's that song, right? If you've got something cubed minus something else cubed, then it's the song. I'm going to do an example of one of those. And then what other types? It might be a what we call a quadratic in disguise, and that's ones where it takes on the quadratic form even if it's not truly a quadratic. So let's do an example of that. Here I'm going to do page 115, number 13. And it is 4x to the 4th plus 3 equals 7x squared. So the first thing you want to do is set this equation equal to 0. So I would subtract the 7x squared. So you're at 4x to the 4th minus 7x squared plus 3 equals 0. And this is one where it's not a quadratic, right? This is actually a quartic, but it takes on the quadratic form. And so I'm going to I use a heart because I want it obvious that I need to make sure I go back and replace it. I'm going to say heart is equal to the middle variable, x squared, and then heart squared would be x squared squared, so x to the 4th. And so this ends up becoming equivalent to 4 heart squared minus 7 heart plus 3 equals 0. And then you need to factor it, right? And so you're looking for two numbers that multiply to 4 times 3, which is 12. They add to -7, and that would be what? -4 and -3. So one way to do this is to break up that middle term and write it as 4 heart squared minus 4 heart minus 3 heart plus 3 equals 0. And then you do some factoring by grouping. There's a 4 heart in common there, which would leave you with a heart minus 1. And then the second two, what do they have in common? A -3. And when you factor that out, you've got -3 times heart minus 1. And your parentheses match, and so that's one of your factors. So one of your factors is the heart minus 1, and then the other one is 4 heart minus 3. All right, now, here's the deal. Right now, go back and do your heart replacement surgery, right, and replace those hearts with x squareds. X squared minus 1 and 4x squared minus 3. I'm going to go ahead and just set these factors equal to 0. X squared minus 1 is the difference of two squares, so you could factor that more. In fact, you know what? That's what I'll do. I'll go x squared plus 1 is actually something squared minus something squared, so it factors as x plus 1 times x minus 1. And then we still have the 4x squared minus 3 equals 0. And so setting each factor equal to 0, you're going to have a x plus 1 equals 0 will give you a negative 1. You're going to have an x minus 1 equals 0 will give you an x equals positive 1. And then this guy will be you would set it equal to 0, add the 3 over, divide by 4, and so x will equal plus or minus the square root of 3 over 4, which is plus or minus rad 3 over taking the square root of 4. Now you no longer have a radical on there. And so you should have 4 answers. Fundamental theorem of algebra says this is an x to the 4th, so I have to have 4 answers, and I do have 4 answers. 4 answers, right? You've got, circle a different color, you got negative 1, you've got positive 1, and you have positive rad 3 over 2 and negative rad 3 over 2. 4 answers. All right, so that was that type. It's that quadratic that's in disguise. It's in quadratic form, and you can factor it like it is a quadratic, even though it's not. Let's do same page, number 19. 8x cubed minus 27 equals 0. You definitely want to look and see, is there a common factor that can be factored out, and there's not. Between 8 and 27, there's not a common factor. But this is the difference of two cubes. And so it is the song, where you go and you take the cube root of the first, which is 2x. You take the cube root of the last, which is 3. Keep the sign in the middle. Then square the first. Now when I say that, I'm talking about this guy right here. So that's a 2x squared. Change the sign, so a plus sign. Multiply together, so a 2x times 3. And then square the last, and the last one's always positive. All right, so that means I've got a 2x minus 3 times 4x squared plus 6x plus 9. Now what will happen every single time is this second factor right here is always going to be what we call an irreducible quadratic, and that means that you have to use quadratic formula for it because you're going to get 2 imaginary answers. I know you're looking at that and you're probably like, oh, I can come up with 2 numbers that I can factor that. No, it will never factor. It will absolutely always be 2 imaginary answers. And so setting each of these guys equal, each of these factors equal to 0, you're going to get an x equals 3/2 for the first factor. For the second one, when you set that equal to 0, you need to use quadratic formula. Quadratic formula is x equals negative b plus or minus the square root of b squared, that's 36, minus 4 times a times c, all over, the whole thing is over 2 times a. And so that'll give you a negative 6 plus or minus, that is a negative square root of negative 108 all over 8. And rad 108 will become 6 rad 3. So this is a 6i rad 3 all over 8. And then a 2 goes into all of those, so I'm going to factor out a 2 from the top. I would be left with a negative 3 plus or minus 3i rad 3, and that's all over 8. And 2 goes into 8 4 times. So I'm going to divide the 2, that's going to be left with a 4 down there. And so these solutions are -3 plus or minus 3i rad 3 all over 4. And so we should have had 3 answers. And I've got one right there. The 3/2 is the only real solution. And then I've got 2 imaginary solutions right here for a total of 3, since fundamental theorem of algebra says you must have 3 zeros, right? 3 solutions. Those solutions may be real, they might be imaginary, they might have multiplicities, but I should have 3 solutions. So that is that one. Let's do another one that is a quadratic in disguise. This is from page 85, number 37. X minus 4 rad x equals 21. So first step, of course, is set this guy equal to 0. So I'm going to subtract the 21. And then it's not a quadratic, right? But it takes on the quadratic form, right? That's why we call it a quadratic in disguise. If I let heart equal the variable that's in the middle, the square root of x, heart squared will be square root of x squared, which is just x. So that means I could rewrite this guy as heart squared minus 4 heart minus 21. And that factors like a quadratic, right? 2 numbers that multiply to -21 but add to -4 are a heart minus 7 and a heart plus 3. And so now do your heart replacement surgery right now, right? You're all going to be surgeons. Plug back in that rad x into that heart, and then we'll continue to solve. All right, so this is setting each factor equal to 0. You're going to get a rad x is equal to 7, or a rad x is equal to -3. And then squaring both sides, you'll get x equals 49. I know right now the square root of x has to equal positive, so I can throw this out. If you don't see that, then when you square it and you get 9, plug it into the x, right? You want to watch out for extraneous solutions. If you get x equals 9, 9 is not a solution, right? If you solve for x, you would get x equals 9, but then when you plug it in, 9 minus 4 times rad 9, is that equal to 21? And that's a 9 minus 12, which is not equal to 21. So that's why that one gets thrown out. 49 works though, so if you checkity check yourself, then you're going to be golden, right? Your answer should be just fine. This is 4 times 7, and that's 28, and so 49 minus 28 is 21. So you've got one answer only, and that is 49, which totally matches up with fundamental theorem of algebra, which says I've got an x here to the power of 1. That is the highest exponent. This is a degree 1, and so you should just have one answer, and that's all I've got. Okay, that is that kind. So you're going to have lots of other quadratic equations to solve. But those are just some of the more trickier ones that I thought I would go over. What else? When we talk about parabolas or quadratics, a quadratic is a parabola, right? And so that's not really where I want to do that. I would rather do it there. Okay. All right, so a quadratic is a parabola. So a y equals x squared is a parabola. And here's what we know. If a ball gets thrown up, it must come down, and it will always be in a parabolic shape like that. And the maximum happens there. The max height is always at the vertex. The max height is at the vertex, and it'll be your x value will really, it'll be t for time, and then the y value is going to be your height of your ball or whatever thrown. So page 86, number 47, says a ball is thrown vertically with a height of, given by s of t, so instead of x they used t, not a big deal, negative 16t squared plus 22t plus 6. That is an opening down parabola, right? And the max height is at the vertex. And so what you want to do is find the vertex. And if you remember, your vertex is going to be the x part, or in this case the t, is going to be negative b over 2a, which will be a negative 22 over 2 times negative 16, which will give you a positive 11 over 16. Well, that's not a friendly number. Hopefully we give you something friendlier. And then the height at that vertex, which will give you your maximum height, will be s of, you're going to plug 11 over 16 into the equation. 11 over 16 squared plus 22 times 11 over 16 plus 6. And I get that it is 217 over 16. I didn't. Okay, so, or if we're approximating, so this is an exact answer. That's exact. Exact answers means you're going to leave it as a fraction or a radical or whatever. Or if it's approximate and they tell you to like round, then it would be what, 13.5625. So let's say 5, 6, and then I think the problem was in feet. Not positive, but maybe it was meters or something like that. But there you go. So if they ask you for exact, you're going to give me 217 over 16 feet. But because it's like a word problem, it'll probably tell you to round to a certain decimal, read the directions, and that will tell you what to do. All right. Another type of problem we can give you is if we give you a solution, so given a solution or a root or a zero, those are all the same thing, and then we ask you to find the quadratic equation. All right, so one like that is like page 84, number 19, and they tell you find the quadratic equation given that one solution is negative 1 plus 2i. And so what you need to remember is that complex roots come in pairs. They always come in pairs. Well, as long as you've got integer coefficients, but that's all you're going to see this year are ones that are integer coefficients. So if I have negative 1 plus 2i, then that means I also have negative 1 minus 2i is also a solution. So that's one thing you've got to know. If I have a plus bi, I also have a minus bi. So you're going to come up with the second one. And then I feel like the easiest way to do this is to do the sum product rule. And so you're going to add them up to find the sum. It's a negative 1 plus 2i and a negative 1 minus 2i. And when you add them up, your i's go away and you're left with just negative 2. And then the product, you'll multiply them, negative 1 plus 2i and negative 1 minus 2i, but this is going to end up being the difference of two squares. It's a plus b and a minus b, so it's a negative 1 quantity squared minus 2i quantity squared, which is a 1 minus 4i squared, and if you remember, I squared is negative 1, so this becomes a 1 plus 4, because I squared right here is negative 1. So you're going 1 minus 4 times negative 1. So you end up adding that and you get a 5 for the product. You're going to plug that into x squared minus the sum of the two zeros or roots times x, and then plus the product of those two roots equals 0. If it's an equation, you should have an equal sign in your answer. So x squared minus the sum is -2, so minus a negative makes it a plus 2x, and then plus 5 equals 0. All right, so make sure it's minus the sum. So you'll take the opposite in sign of the sum for your equation. Don't forget the equals 0. And yeah. All right, let's talk about types of solutions. Yeah, types of solutions. So that's when you use the discriminant, which is the part that's underneath the radical of the quadratic formula. It's the b squared minus 4ac. And if that number is positive, so greater than 0, then you are going to have two unequal real roots. I'll just write real, right? Or solutions, right? And then if your b squared minus 4ac, if your discriminant is equal to 0, then that means you're going to have two equal real roots. You may have heard them called one double root. That's true. I personally prefer that you write two equal roots or two equal real, so that it matches up with fundamental theorem of calculus, right? But it's a double root, or you know now, multiplicity of 2, right? That's what that's saying. And then if the discriminant is less than 0, then you have two complex conjugate roots. That means they're imaginary. Two complex conjugate roots. And yeah, they're imaginary. And they always come in pairs, right? A plus bi and an a minus bi. So anyway, all right, so let's do an example of that. Page 84, number 9, says to find the, I don't know, describe the types of solutions or something like that as the directions for 3x squared minus 4x minus 2 equals 0. And so here your a is your a is 3, your b is -4, and your c is -2. And we're going to plug that into b squared minus 4ac. B squared minus 4ac would end up being -4 quantity squared minus 4 times a times c. You're going to make sure you include all those signs and stuff. When you plug a number into something squared, there are parentheses around it, so that means that that -4, when you square it, becomes a positive 16, and this will be a, what, plus 24, I believe, which is 40, which is greater than 0, and so your answer would be two unequal real solutions. Okay, so that is that time. The other thing we're going to have you do is graph quadratic functions. So let's do page 115, number 15. And they want you to graph and find all kinds of info, right? -2x squared plus 4x minus 3. Okay, so we're going to graph it. We're going to find axis of symmetry. We're going to find the vertex. We're going to find x-intercepts, y-intercepts, and we're going to, I think I already said graph it. All right, so let's start with the vertex. Or let's start with the axis of symmetry, I guess. Axis of symmetry is going to be x equals -b over 2a. And you must include the x equals because the axis of symmetry is a line. So you need the equation. You need x equals. So that means it's a x equals -4 over 2 times -2, which ends up being a 1. And so your axis of symmetry, what you're going to write is x equals 1. You will get points off without the x equals because it is the axis of symmetry. It needs to be a line. The vertex, the x part of the vertex is going to be the exact same value you just found for the axis of symmetry. So the negative b over 2a we just found. And then you're going to plug that value in and solve for y to get the y part. So we just found that 1 is the x part. I need to find the y part. And so I'm going to plug it in. So your y will equal negative 2 times 1 quantity squared plus 4 times 1 minus 3, which will give you what? Negative 2 plus 4, so a negative 1. And so your vertex is a point, and it's 1, negative 1 for your vertex. Y-intercept is the super easy one to find. Y-intercept is when x is 0, what's your y? So I'll plug in a 0, but you know it's going to end up being that c value every time, right? Hopefully you notice that. If I plug in a 0 into x, you end up with negative 3. So 0, negative 3 is your y-intercept. I guess I should have written that, but your y-intercept will always be 0, c, where this guy right here is your c, the negative 3. Because once you plug in 0 into x, the x's go away, you're left with just the y value. Okay, so there's your y-intercept. We're also going to ask you for the x-intercept. So to find the x-intercept, that's when you have to solve. It's the same thing as solving this equation. Or that's the process you do anyway. So for x-intercept, that means we need to figure out what x is when y is 0. So I'll plug a 0 into y, and I want to solve for x. So this is where if it factors, that's going to be your fastest usually. You could complete the square. I'm not going to choose to complete the square. We're not going to get out of completing the square. We do have to do it, but not on this one. I would do quadratic formula on this one. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And so you end up with negative 4 plus or minus the square root of negative 8 all over negative 4. Here's the deal. I can just stop right now because these are imaginary. And when you get imaginary, those are imaginary. If I can write imaginary, when you get imaginary solutions, then there are no x-intercepts. So if I give you the directions solve this equation, okay, you would keep on going, you would simplify, and you would give me the answers for a solve. What are the solutions? What are the zeros of the equation or whatever? These guys are imaginary ones. And so when you get imaginary, your answer is none. There are no x-intercepts when you get imaginary roots. All right, and then we're going to graph it. And hopefully I left myself enough room to graph it. Let's see what we got. Oh yeah, it should be fine. Okay. Boop, 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 boop. Nope. Undo. Okay, and can I grab it? Let's see if it'll let me grab it. Oh, good. Because I really did not want that so low. That'll work. Okay. So we want to graph, let's graph the points we've got, and hopefully that'll be enough. I've got an axis of symmetry going through x equals 1. I have the vertex at 1, negative 1. There's your vertex. I have a y-intercept of 0, negative 3. there. Here's what other thing I know is by the axis of symmetry, if I have this point 0, -3, which is 1 unit away from my axis of symmetry, I'm also going to have a point 1 unit away that way as well. And that's good enough. It's opening down because of the -2 as the leading coefficient. It's got the vertex there, and notice there are no x-intercepts there. Makes sense, right? It's opening down and it's already below it, so it'll never cross the x-axis. So there you go. That's graphing from standard form and finding all this information. Make sure also that you know how to go backwards. Know how to work backwards as well. We did that in the notes. So where you are given the graph and you need to come up with the equation. You find the equation in vertex form. So make sure you know how to go backwards, where you're looking at this and you're like, okay, here's the vertex is at 1, -1, and then notice that instead of going right 1, up 1, you went right 1, down 2, so your A is -2, and anyway, so make sure you know how to do backwards because that will also be on the test. Okay, let's do another type. Page 113, number 2. This time I want you to convert to vertex form. So given f of x is equal to 1/4 x squared minus 2x plus 3. Convert it to vertex form and then we'll find all of that information also. So a couple ways of doing it. The PowerPoints we showed you added and subtracted on the same side of the equal sign. I think I'm just going to show you old school and go, okay, f of x is y, subtract over the constant, leave a little space, factor out the coefficient in front of x squared. Be careful here, when you factor out a 1/4 from -2, that becomes a -8x, and I'm leaving a little space there to complete the square. You complete the square by taking the coefficient on x, which is -8. I'm going to take that, I'm going to cut it in half, so -8, cut it in half, and then square it, which will be -4 squared, which is 16, so I'm adding 16 here. But be careful, because when you go to add that to the other side, you don't add 16, because what you really added was 1/4 times 16. So that's a plus 4. And then this is a y plus 1 equals 1/4 times x minus 4, quantity squared. And then last year your book left it like that. This year, I believe, yes, your book rewrites it so that it's, actually, I'll go down this way. We subtract the 1 over, so we got y equals 1/4 times x minus 4, quantity squared minus 1. All right, there's vertex form, right? And then you can identify the vertex immediately, right? Super easy. Your vertex will be, you know what, actually, should I go to the next page? I think I'll go to the next page. I'll rewrite it. So y equals 1/4. So it's still the same problem. I'm just going to answer more information about it. Okay. All right, so the vertex, super easy to see that it's a +4, -1. Inside parentheses, opposite in sign. Outside parentheses, same sign. So your vertex is that guy. Your axis of symmetry is going to be x equals 4. Don't forget the x equals. Your y-intercept, oh, I didn't include the original. It's when x is 0, and so if you look back at the original 0, c, that c value is a 3. I'll do that. And then your x-intercept, you got to set y equal to 0, and do I want to do that? It's probably easier to do it from vertex form. I didn't do it doing vertex form though. Let's do vertex form. Okay. Okay, so let's see, you would subtract the 1. You would multiply both sides by 4. Nope, I'm doing something wrong. Oh, because there we go. Okay, let me fix this real quick. Sorry about that. Let's select this guy, and I'm going to trash it. And this guy, trash. Sorry about that typo. Okay, let me go back and fix that. Okay, so I wrote the problem wrong. It's a 1/4 x minus 4 squared minus 1. Right, and then that means I would add the 1 over to the right-hand side. So you got a positive 1 over there. Multiply both sides by 4. You get 4 equals that. Take the square root of both sides. You're taking the square root of x squared, so it's a plus or minus the square root of 4, which is 2. And then add 4. So 4 plus or minus 2 is equal to x. That simplifies. Don't you dare leave your x-intercepts like that. It's 4 plus 2, which is 6, and 4 minus 2, which is 2. And then your x-intercepts, you're not going to leave them as 6, 2. You're going to write them as ordered pairs. They're both when y equals 0. So it's a 6, 0 and a 2, 0 are your x-intercepts. Ordered pairs when y equals 0. All right, then I'll graph that and try that again. Okay, and I need, what do I need? I need the vertex at 4, -1. 1, 2, 3, 4, -1. Okay, so there's my vertex. I've got the axis of symmetry going right through x equals 4. I've got the y-intercept of 0, 3. And then this time I have x-intercepts at 2, 0, and then also at, at 6, 0. Let me do a different color. Come on. There's my other one. There, here, here, here. Okay, so there's my points. That's good enough, right? So your parabola opens up, and it keeps on going that way. I ran out of space, and then, whoops. Pretend like I can, okay, that was way off. Boop. All right, whatever. This thing is really hard to draw on. Sorry about that. So there's your parabola opening up. And again, make sure you know, like, can you look at this graph and come up with the equation by looking at it? And hopefully by now you can. Okay, what else? Let's do one like page 104, number 1. Tells you to find the max perimeter of a rectangle where the top vertices are on the curve of the parabola y equals 12 minus 0.2 x squared, and the bottom is on the x-axis. So we did one like this in class. Look in your notes. They're in your notes. So this is a opening down parabola. And what it's saying is that there is a rectangle where the top of your rectangle are corresponding to these points on the parabola, and the bottom is on the x-axis. Okay, so what you got to keep in mind, I placed this just perfectly so that it's centered on the axis, right? So that I'm going to let this distance right here be x, and then that means this ordered pair, the point that is right there that corresponds, that's on both that rectangle and the parabola, is x comma the y function that they gave us, 12 minus 0.2x squared. Okay, and they want us to find the maximum perimeter. So the perimeter, if you remember, is 2 times the width times 2 times the length, where here the width of your rectangle is this, whole part is your width, and so that'll be 2x because you got x plus x, and then your length is that guy. I know I didn't draw it with like that, but whatever. Okay, so the width is 2x, and your length is going to be 12 minus 0.2x squared. So the perimeter will be 2 times the width, so 2x, 2 times 2x, and then plus 2 times the length. And then that will give you a 4x plus 24 minus 0.4x squared. I'm going to rewrite that so that it looks like a quadratic. I'll write it as a negative 0.4x squared, and then a plus 4x, and then a plus 24. So that way it looks like a quadratic. Remember what we talked about maximum. Your max is at the vertex. They wanted max perimeter. So the max perimeter is at the vertex. Maximum is always at the vertex. So we've got, I'm going to draw a little, give myself some room over here. So we've got, to find the vertex, it'll be x equals negative b over 2a. And so that's a negative 4 over 2 times negative 0.4, which ends up giving you that x is equal to 5. And then the perimeter, so that's the x value of this perimeter equation, which happens to be a parabola, right? So the perimeter is going to equal, you're going to plug in that 5. Negative 0.4 times 5 squared plus 4 times 5 plus 24, which will end up giving you 34, and that will be the maximum perimeter for this rectangle. And I don't see, if they gave me units, I didn't write them down. So, okay. Moving on. You have a whole bunch of, we had that whole section of coordinate proofs. Lots of things we can ask you. It's really hard, like there's so many, I can't really narrow it down for you. But make sure for these coordinate or geometric proofs, that last one was like a coordinate proof also. But some geometric proofs where we use like geometric shapes. Remember that the distance formula between 2 points, the distance is equal to, it's Pythag, the distance is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. There's the distance formula. Midpoint formula is you add the x's and divide by 2, and you add the y's and you divide by 2. It's a point. The midpoint is a point, and so it's got an ordered pair. Some things you should know are that a rectangle has opposite sides that are parallel, and opposite sides are congruent, and slopes are perpendicular. That's what makes it a rectangle. A square has, what did I put? All four sides. So all four sides are congruent. And then you're going to have opposite sides are parallel, and you're going to have slopes that are perpendicular. A parallelogram. Parallelogram has opposite sides that are parallel, and opposite sides are congruent. But their slopes aren't perpendicular. That's the difference with the parallelogram. They don't have to be that. Trapezoid has two sides that are parallel. The other two are not. And then an equilateral triangle has three sides that are congruent, three equal sides. Isosceles triangle has two sides that are the same. All right. Let's see here. Okay, so I'll do an example. Doesn't mean that this is the one that's on there. Just trying to give you an example of what to do. Page 104, number 10. If I want to prove the diagonals of an isosceles trapezoid are equal. We're going to also tell you, no matter what shape it is, to draw and label your figure in quadrant 1. Okay, so let's draw quadrant 1 like that. Okay, and then if I draw an isosceles trapezoid, that means I'm going to have, oops, I'll start here at the origin. I've got this line here, it's straight, and then it's down like that. Okay, so I've got this point is at 0, 0. If I call this point here at a comma 0, and then I'm going to call this point right here b comma c, because your y value has nothing to do with that guy, and then b is just how far over you went on the x value. This point right here will have the same y value as this point, so it'll be c, and then the x value will be a minus b. All right, and let me label these as, let's go with, I'll label them as, this is point A, B, C, and D, just to make my life easy. And so what I need to show that the diagonals are equal. So I need to show that AC is equal to BD. And what formula am I going to use? I'm going to use the distance formula. I think we ask you to name like what formulas you used or whatever. So I'm going to use the distance formula to prove that. All right, so YAC equals BD because those are your diagonals, right? Okay, so let's do AC. It will equal the square root of a minus b minus 0 squared plus c minus 0 squared. And that ends up equaling the square root of a minus b quantity squared plus c squared. And then stop. Don't you dare take the square root of that guy right now, because then you're wrong. You're going to lose points. Because of this plus sign, you cannot write it. It's not equivalent to a minus b plus c because of that plus sign. The plus sign in between the two squareds. So you can't simplify that. You're done there. So let's find the length of BD. BD would be technically, I guess we go b minus a quantity squared plus c minus 0 squared. And that is equivalent to b minus a quantity squared plus c squared. And just so you know, if you subtract a minus b and square it, you will get the same thing as b minus a when you square it. Those guys are equivalent. So these guys are equal. And then don't forget, you must write your English conclusion. You don't get points if you don't. And so I would write, since AC is congruent to BD, then the diagonals of an isosceles trapezoid are congruent. Probably had a congruent sign up there. Okay. All right. There's how you're going to prove that. And again, lots of ways of doing it, or lots of different types of questions we can ask you. I gave you a list of different things you could use, or we could ask you about parallelograms or trapezoids or triangles or squares or rectangles, and something in there. All right, last little bit, and that is the distance from a point to a line. So the distance from the point to the line is given by the absolute value of ax1 plus by1 plus c, and then all over the square root of a squared plus b squared. So as long as, this is when you're given ax plus by plus c equals 0, so this is your line equation is given in that form, and they've given you some point x1, y1. So given an equation of the line where it's in standard form like that, and then a sum point. So let's do page 115, number 26, and I guess I should look to see what it was, because 115, number 26. So find the distance between these two lines. Find the distance between, they gave us two lines, 3x minus 2y equals -5, and the line 6x minus 4y plus 8 equals 0. And they want us to round to the nearest hundredth. So what you want to do, if they give you two lines, we want the distance between them. So what you need to do is identify a point on one of the lines and then use the other line as the line. Right? So we're only going to use one of these equations as the line, and the other line will find an exact point on it. Any point on there will work, and we'll find the distance between them. So I'm going to use the equation of the first guy. I'm going to use this first guy as the line. So I need to add the 5 over first before I can identify C. And so now your A is 3, B is -2, and C is a +5. I'm going to identify a point on the line here, You can choose anything you want. I'm going to choose something easy, like if I plug 0 into x and then I solve for y, I would end up getting 2 for my y value, right? If I just plug it in, and so I'm going to let x1 equal 0 and y1 equal 2. And again, all I did there was say I need to find some point on the line. This isn't the only point you could use. You could find any point on the line. I just tried to do something easy. I saw 4 went into 8, and so I guess I should have showed you the work. I went, okay, 6 times 0 minus 4y plus 8 equals 0. And so that goes away. You got negative 4y equals negative 8, which gives you y is 2. So I plugged a 0 into x. You could have chosen anything. You could have chosen a 1 to plug in. I just was trying to do something easy peasy and simple. Plugged a 0 in, solved for y, got this point that I'm going to plug in. So now that means that the distance is equal to absolute value of a times x1, I chose 0, plus b, negative 2, times y1, I found was 2, plus your 5 for the c, take the absolute value of those, all over square root of a squared would be 9, b squared would be 4. And so that ends up giving you what? 0 plus negative 4 plus 5, so a 1 over rad 13. And then it said to round to the nearest hundredth, I believe, and so 0.28 is the distance between these two lines. Not the only numbers you could have used. We could have used the second equation as your line and then found a point on the first guy. I noticed this 4 and this 8. That 4 goes into it evenly, so I could get away with using a point that didn't have any fractions and nice and friendly and stuff. So that's why I did that, but not the only way. Okay, that is it. Other than you will also have a word problem where you have to apply this distance from a point to a line. So make sure you also practice a word problem with the distance from a point to a line. So the notes are good, right? So it'll be something like you either have notes, it's example 3 was an application to it, or you had a couple of homework problems, and that was like, I should give you the page number first. It was page 111, and it could be something like number 12 or number 14 or number 16, or I didn't look at those worksheets that we gave you, but those are fabulous. So if there's a word problem on there, that would be good as well. So, all right, that's it. Good luck on your test, and you'll do great, I am sure. Talk to you later.